Good morning, everybody. I hope that we're doing all right, and I hope that we're having a great start to our week and a great week so far. Today's video is going to be all about direct variation, which is still very much related to slope and everything like that. So, without further ado, let's get to the video.
Today, we will be talking about direct variation, and at the end of this video, I hope that you're able to write and graph an equation of direct variation. So let's start with what a direct variation actually is with our key concepts of vocabulary. So a direct variation is a linear function defined by an equation of the form y equals k times x, where k cannot be equal to 0. It's also important for us to know that k is our constant of variation, and we can find that out by doing y over x. Now, you will also remember, if we think back into 7th grade as well, we had a constant of proportionality that was actually also labeled as k. So constant of proportionality and constant of variation are also the same exact thing. We can also see that the graphs of direct variations, they have to go through the origin. They have to go through 0, 0, and the slope of the line is that constant of variation. It is that constant of proportionality. Okay, so let's try a couple of examples in regards to direct variation. So for each function, tell whether y varies directly with x. If so, find the constant of variation. So really what they're asking us to do here is they are asking us to write this in slope-intercept form, which means we need to rewrite some stuff. So for part A, all I'm going to do is I'm actually going to divide both sides by 3 because I'm trying to solve for y. So I'm going to have y equals 7/3 x plus 7/3. But I can tell you, just because of this plus 7/3 here, it is not a direct variation because of that plus 7/3 constant on the end there. So no, it does not vary directly with x. For part B, it's a little bit different though. I can divide by -2 at the start, and I see that I have -5/2x equals y, and that actually follows that same format for a constant of variation, direct variation equation. So yes, y does directly vary with x. Let's try a couple of graph examples, okay? So I look at question A, I have to determine if the graph does a direct variation, and if does, identify, or if it does, identify the constant of variation. I can already tell that graph A is not going to be a direct variation because I can see it's not going through the origin. It's going through somewhere up there, not through the point 0, 0. So that's exactly why it's not, okay? When I look at part B, I can automatically see that it goes to the origin, so that probably means that it is a direct variation point or direct variation graph. Now I need to figure out what that constant of variation is. And again, this is very much like finding the slope. In fact, slope is essentially your constant of variation. So I can look and see how I go from one point to the next. And I can see, let me just do that one more time. And I can see that I have to go up 3 and to the right 6. So 3 over 6, or 1/2 is going to be my variation, my constant of variation. And then in the last part, for part C, I can also see that it goes to the point 0, 0. So that tells me, yes, this is a direct variation graph. And then when it comes to trying to find the slope, I have to go to right 2 and then down 7. So my k is going to be -7/2, a negative slope, and that's okay. Let's try to take it to some other examples here. Suppose y varies directly with x, and y equals 15 and x equals 27. Write the function that models the variation. Find what y is when x is equal to 18. Now, the first thing that we have to do is we have to identify our constant of variation, which we said was k equals y over x. So I have y, 15 over 27, which that's going to reduce to be 5/9. So if I were to try to write a constant of variation equation, all I have to do is take my constant of variation and do y equals 5/9 x. And that would be my equation. if I wanted to figure out what y was when x is 18, all I have to do is just take 18 and plug it in right here. And when I do that, so y equals 5/9 times 18, that's actually going to come out to be 10, because the 18 and the 9 cancel out. 18 becomes a 2, and 5 times 2 is 10. Now let's look at it as a table, okay? All I need to do, just like in 7th grade, I just need to identify what my constant of proportionality, what my constant of variation is, what my slope is. They are all the same thing, just with rate and ratio, okay? I need to make sure that it's the same throughout. So for part A, I just have to do y over x a bunch of times. So 3 divided by -1 is going to give me -3. -6 divided by 2 is going to give me -3. But 15 divided by 3 is just going to give me +3. So this is not a direct variation function, because my constant of variation doesn't remain the same throughout the entire table. Now I need to try this with B. If I do 14 divided by 7, I get 2. If I do 18 divided by 9, I also get 2. And if I do -8 divided by -4, I get 2. So yes, this function varies, y varies directly with x for this function. And the constant of variation, k, is 2. Now I have one more example for us, and then that will be it for the day. Another kind of real world example here. Weight on the moon, y, varies directly with weight on Earth, x. So I know that y is the weight on the moon, and x is the weight on Earth. A person who weighs 100 pounds on Earth, so I'm going to make sure I highlight that in orange. 100 pounds on Earth weighs 16.6 pounds on the moon. What is an equation that relates weight on Earth, x, and weight on the moon, y? And how much will a 150-pound person weigh on the moon? So again, the first thing that I have to do is I have to figure out what my constant of variation is. So it's going to be k equals y over x. So y is the weight on the moon, so I know that this is going to be 16.6, and x is the weight on the Earth, divided by 100. So what I have to do is I just need to simplify that, okay? So that is going to simplify to be 0.166, 0.166. Now I have my constant of variation, and I just need to put that into my formula. Again, the formula is going to come out to be y equals kx, whatever my constant of variation is. So this is going to be y equals 0.166 times x. In order for me to figure out how much a 150-pound person weighs, that's 150 pounds on Earth. So what I have to do is I have to take that value and throw it in where x is. So this would be y, whoops, let me erase that. So this would be y equals 0.166 times 150. And that would come out to be roughly 24.9 pounds. So I'm going to make that a squiggly equal sign there, 24.9 pounds. So that's exactly how we use direct variation. It's very much related to our concept of proportionality, very much related to slope, rates, ratios, all of that. They are all coming connected, and I hope that you can see the connection even from prior to 7th grade when we are talking about direct variation. So if you have any other questions, please leave a comment on the YouTube video or feel free to message me on Schoology. But I hope that you have a great rest of your day, and I'll see you next time.